So today we're going to be talking about limiting reagents, calculating theoretical yield, calculating percent yield, stoichiometry, and balancing equations. So we're going to start out by balancing this equation. So we need to balance C3H8 plus O2 and CO2 and H2O. So the last thing we're going to do is balance our O's. So we'll save those for the very last thing. We can see that we have 3 C's here, so let's go ahead and put 3 right here. And we can see that we have 8 H's over here, we have 2 over here, so what times 2 equals 8? Well, that's 4. So, the way we balance this, we only need to put a 1 here, and our total of O's, we have 3 times 2, that's 6, and 4 O's over here, so 6 and 4 are 10, and we have a 5 over here. So, what times 2 equals 10? That would be 5. So, let's go ahead and figure out what our limiting reagent would be in these equations. So let's say we have 2 moles of C3H8 and 3 moles of O2. So, which one is the limiting reagent? So, let's write down what we know. We know that there are 2 moles of C3H8, and we know that there are 5 moles of O2 in this equation, and there's only 1 of these. So we can cancel these out, and we get 10 moles of O2. And so we know that we have 10. 10 is greater than 1. 10 is greater than 1 mole of C3H8. And so if that didn't tell you that, if you couldn't figure out that so you can figure that out, that 10 is not your limiting reagent, then you could always do your other way. You could always do your second. So you could go ahead and go through and do 3 moles of O2 and your 5 moles of O2 from your equation. You could do your 1 mole from the equation. And that would get you 3 over 5. And so obviously from that you can tell that 3 moles is less than 5. So clearly the C3H8 would be your limiting reagent. So we have, once again, we have our equation at the top. So let's figure out what your theoretical yield is of water. So for theoretical yield, let's start with our 5 grams. That's our very first thing we need to start with. I've already calculated this out for you. So grams from the periodic table. So there are 44.364 grams, and I'll put that over under 1 mole of C3H8, and then that's going to be times these 4 moles. We're going to bring those down here, and so once again, sorry, things that cross out, these 2 cross out, and these 2 cross out. So then we're going to put this 1802, which I've already calculated out for you ahead of time, for the water. And so you have 4 moles of H2O, and put 1 mole of H2O on the bottom. H2O moles cancel out, and then we're left with 1802, so 18.02. So what I've already done for you is I've already calculated it out. You're going to get 8.12, and then that just keeps going on and on and on. So then, we're going to change that into sig figs. So you'll notice that in the problem, I give you 1 sig fig. So, and this would not round up, so we'll just say 8 grams. So now, let's say I actually do that. I go ahead and I do this equation. I get my oxygen, my C3H8, my propane, and that's going to give me water with the CO2 gas up here. So, once again, you have your equation at the top here. So, let's say I got 6 grams whenever I did this, 6 grams of water. So, percent yield, let's figure out percent yield from that. So, we have 6 grams of water. I've showed you that we got 8 grams is your theoretical yield, but that's your actual yield. So you put that over your theoretical yield, so actual yield over theoretical yield. So I can do that one in my head. So that one will come out to be 0.75. And then to get that into a percent, you're going to do that times 100. So 0.75 times 100, you're going to get 75%. And you can always put that into sig figs too. If you wanted to, you could make that 80%. Okay? I hope you enjoyed, and thank you for watching.